Error handling. Hello, this is Ben Finkel, and in this nugget, we're going to take a look at how you can handle and trap and report on specific errors that come up when your Python program executes. Now, error handling is a really important basic task that you need to perform inside of any code that you write. Unfortunately, we're human and we're always going to write code that is prone to producing an error. So we're going to take a look at why we need error handling in the first place, why we should be handling the errors as opposed to just letting the computer handle them. After all, computers are good at that kind of stuff, right? Then we'll take a look at the basic error handling structure, which is a try-except statement in Python. We'll talk about how we can accept specific types of errors so that we can catch and create output based on the type of error that might come up inside of our program execution. And then we'll finish with a quick look at the else and finally clause of the try-except statement, a way to run code under different scenarios based on what happens with our error handling, our error trapping statement. Let's take a look. Computers are pretty dumb. And I know what you're saying to yourself. You're saying to yourself, that can't be true. Computers perform incredible math calculations, lightning quick, faster than I could ever imagine. They do all kinds of scientific tasks and automation tasks that, as people, we could never do, at least not at the speed and level of precision that we need them to be done at. And my answer to that is that doesn't demonstrate that computers are smart, simply that they're good at following directions and they can do so quickly. They're fast. But ask a computer to recognize your grandmother and it's going to stumble pretty quick. And as good as we are getting these days at enabling computers to do things like recognize somebody's grandmother, they're still only in the infant stages of it, and everything that they do is dependent upon what they have been told to do or instructed to do by programmers, by people like you and I. They will follow the directions that we give them, that we key into that program, and they will follow those directions to a fault. And I don't say almost to a fault, I mean to a fault. If you give a program bad directions, it's going to run into a problem. And when it runs into that problem, we call that an exception. Eventually, at some point in our programming careers, we're going to write some code that has a problem in it. We are going to cause an exception to get raised. And that's what we talk about when the computer executes one of our pieces of code to that fault. It's called raising an exception. And everyone is going to do this. Everyone needs to deal with it. One of the most important administrative tasks that we as developers have to take care of, that we have to address, is having good error handling in our code. It's not as cool and neat as writing the actual code itself, but it is so important for writing clean, usable code. So take a look at this code I got on screen here. It's pretty straightforward. All it does is ask for a couple of values, x and y, and then solve an equation based on what the user keys in for those values, x and y. And this will run. This may look like very good code. What's the problem with this code? How could this cause any trouble at all? Well, I can see a whole bunch of problems here, but rather than talk about them, let's take a look at them. I've got it up in my demonstration box here. So let's go ahead and execute this program, see it run in action here. Enter a value for x. I'll say 40, and enter a value for y. Let's say 30. And it tells me that solving that equation for 40 and 30, we get the result 2.0. And I think that checks out. I can do my math. 40 divided by 2 is 20. 40 minus 30 is 10. 20 over 10 is 2.0. That checks out. Problem. All right. So what's the problem with this program? Well, I can break it pretty easily. Imagine the things that I, as a user who doesn't know how the program really works, doesn't know how it's supposed to be used, might do. I might come along here and I might say, you know what, 40 and 30. Whoa, what happened here? Well, I got an error, and you can see that it's telling me the name 30 is not defined. It's my error message right there. That doesn't mean a whole lot to me as a user. To us as developers, we can look at that and we can say, oh, I know what happened. It tried to turn the text 30 into a float value, tried to turn those letters into numbers, and the computer didn't know how to do that. But the people using our software, generally speaking, are not programmers. They're not looking at our code, and they're not going to understand error messages like this. In fact, they're just going to be upset. The computer crashed, right? The program stopped working because apparently someone did something wrong, but they don't think they did anything wrong. So this is a really poor way to have errors handled. And you might say to yourself, all right, well, that's kind of an outside shot, right? People aren't going to type in letters when it's asking for numbers, although you'd be surprised what people will do. And to that I say, all right, fair enough. Let's stick to numbers. Let's see what else we can do to break this program. I might come along here and say, all right, I'm going to put in 40 for x and 40 for y. It crashed again. Once again, I've put in what I think are perfectly valid responses to the questions that were being asked of me, and I got a whole bunch of garbly looking code back, error messages back, and I don't necessarily know what they mean. Again, as developers, we can look at this and say, float division by 0. You can't divide by 0. When it went to perform the math calculation, 0 was on the bottom of that divisor, and guess what? We crashed because you're not allowed to divide by 0. The computer doesn't even know what to do with that. All of which is a very roundabout way of demonstrating the fact that we need to have proper error handling inside of our programs. So what I'd really like to do when one of these exceptions is raised in my code is, instead of printing out an ugly error message on the screen and crashing the computer out of the program, losing all the work that they've been working on, I'd like to print out a nice clean error message on the screen, something that explains in slightly more user-friendly terms exactly what went wrong, if I know, and what the user can do in order to correct it in the future, and then maybe give them another chance, allow them to correct the problem that's been run into. Or maybe this program is running quietly in the background and it runs into a data record that it doesn't know how to handle. We'd like to write that record out to a log file and then move on to the next record, continue on working. We don't want our whole process, again, to crash just because there was one bad value in the data that we might be processing. We do this with something called a try block, and this is pretty common in procedural programming languages. You have your keyword try, and then your block of code that you are checking for errors, and then you have your catch, or in Python's case, your except statement. And your except statement is really just a bucket. It's a block of code that's going to run when an error occurs, and it's the bucket that catches those errors and handles them for you. And one of the great things about this, in Python and many other languages, is you don't even need one bucket. You can actually have a whole bunch of different buckets. You can have except over and over and over, and you can shuffle different errors into different buckets. So in the case that we just showed, we could have one except statement that's going to handle when the user keys in text instead of a number, and we could have another except bucket that handles when the user keys in two values are the same and we get a 0 in our denominator. And then lastly, we can even finish it off with a sort of generic bucket that handles all the other errors that we don't know about, where we can say to the user, you know what, something went wrong, we don't know what, but here's the output, here's the diagnostic information, do with it what you will. So let's take a look at that code sample we were just working with and start cleaning it up, adding in a little bit of try except statements so that we can handle our errors a little more cleanly. Alright, so here's the next shot at my code, the second iteration of my code, and you can see that I've introduced the try and except blocks. You can see the syntax there, it's just try, colon, and then using the indented block notation in Python, I've got the code that I want to watch or observe for an error. Down here is my except block, and that's the bucket that the code is going to run into if in fact an exception occurs. Now I've wrapped the whole thing in a while loop, and then I allow the user to type 0 if they want to break out of the loop and end the program. So let's see it in action. And first of all, go ahead and say Python error2.py. I'll go ahead and do 40, 30. You can see that it still executes just the same way as before. So because I keyed in proper values, there was no exception run into inside of my code, and this block of code under the except block here never executed. It's sort of like an if-then-else statement. Because I didn't hit that trigger for one particular clause, my if clause, that code was skipped over. It was never run. However, if I come here and I say 40 and 40, like we said, now this should produce an error. And in fact, when that happens, you can see that it tells me, it prints out on the screen just like I wanted it to. There was an error with the code, and then it looped right back around to the top and it's saying, hey, key in again. So there you have it, real basic. That's your first basic type of error handling or exception catching. Now this is a good start, but it doesn't quite handle what we needed to handle. After all, it's not a particularly useful error message that we've given the user. There was an error with the code. Okay, what was the error? So in this general exception bucket that we have here, what we can do is we can actually capture the value of the exception. And we do that by saying catch exception as E. And I'm going to talk a little bit about what this code means. But what you need to know is that you can almost treat it like a function where a value is being passed in as the variable E. And we can handle the error message like so. We can say print error message, And we'll come over here and we'll say string E. So all I'm doing is I'm printing E, which is the variable that's been passed into my exception clause, out onto the screen. Let's see this run in action here. So I'll come over here, I'll execute my program, and again I'll key in 40 and 40. And you can see what happened is it said, okay, there was an error with the code, just like before, but now below that it says the error message was float division by 0. Now, that still may not be super helpful for the user. That's kind of similar to what we were getting before, but at least it's something. It's saying, okay, there was an error, float division by 0. Maybe if your user is paying attention, they might say, oh, yeah, that's right. That's going to cause it to divide by 0. I can't do that. Then they're redirected to the front, and they can come along and key in whatever they were planning to key in to begin with. I actually meant to do 40 and 45, let's say. So by catching the exception as E, you're storing the error information inside of this variable called E, and then you can print it out. And there's a lot of different things we can do with our exception variables. But let's take a look at another thing that we talked about here, and that is the multiple buckets that we have for catching errors. After all, we may want to respond differently based on what kind of error we ran into. And what you can actually do is instead of just catch except exception, you can catch a lot of different types of errors. And to see all the different types, I recommend you check out the Python documentation. Got the URL up on screen here. And that's going to show you all the different types of errors that you can catch inside of your code. But let's take a look at catching some of those specific errors right now. So what I've done here is I've changed my except clause to say except 0 division error instead of except exception as E. And if you're wondering where I got that specific syntax, 0 division error, well, there's a couple of different ways you can get it. The first and the best place to pick this up from, like I said, is the documentation. You can see that right here. Right in the documentation, 0 division error, this page actually shows you all of the different buckets, all of the different exceptions that you can collect inside of your try statement. The 0 division error is the one that I'm interested in particular. It also came up in the Python diagnostic output in my unhandled error exception. So if I run that old piece of code, this is the one that does not have the error handling in it, and I produce my error, you can see right here that on the very first thing it says before the message is 0 division error. So that's another way to get the error type that you might want to handle. That's the exact same spelling and capitalization as it goes inside the except statement here. There's a third way as well we'll talk about a little bit later in this nugget, but now let's see this code run in action. I'll run error 3, produce a 0 division error, and you can see in fact that there was an error in the code, and it tells me I keyed in a value that caused a division by 0. So I could print out that nice, clean, easy to read message because I'm only catching 0 division errors. I'm not catching any other error message. And check out, here's what I mean by that. If I come over here and I say, just put in some letters where it's expecting a number, right? My program crashes again. So on the plus side, I now have a very specific bucket for a very specific type of error, and I can either correct it myself or report back to the user what went wrong. But on the negative side, I've lost some of my clean error handling. What do I need to do? Well, easy. I need to create multiple buckets. So here we go. Look at all the different exceptions that I'm now trapping inside of this little block of code. I've still got my 0 division error to catch when a 0 division occurs, and I've got my name error, and that's going to trap when I try to key in letters instead of numbers. And then down here I've got my sort of general catch-all bucket, catch exception as E, and that's just going to print out the actual exception message so that I have some diagnostic output. So what's going to happen here is each of these buckets is set up, and one and only one bucket is going to be triggered when there's an error in my code. The first time an error comes up in my code, it's going to check it against these buckets in order. Is it a 0 division error? Is it a name error? If it's neither, then it's going to land here in this catch exception as E bucket. So we've got a way to sort of gracefully handle any type of error that we can imagine coming up inside of our code, and we can see it in action right here. First, I'll start with my 0 division error. There we go. You keyed in a value that caused a division by 0. We didn't see any of those other messages print out because they were skipped right over. Same thing if I put in letters for one of my values. You can see you keyed in a text value where a number was expected. So that's really helpful for the user. And the last bucket, catch exception as E, will get called whenever there's any other exception generated in the code, which honestly I can't think of a way to do that right now. So we have good error handling, good error catching on this block of code right now. Now, there's two more additional clauses that we can use inside of a try except statement. Those are else and finally, and let's take a look at how they work now. To begin with, the else clause has to be after all of your except statements. These except statements here can be in any order that we want them in, and they will properly catch, they will properly divert the code into the correct bucket based on the exception that occurs. But the else statement, the else clause, has to be down here at the bottom after all of those except statements. That's where it belongs. And the else clause is going to run if none of the errors were actually caught. If no error, if no exception was raised, then the else bucket is going to get hit. So it's just another bucket, an additional bucket that we can create, but it's the no errors bucket. It's the our code was clean bucket. And what do we want to use this bucket for? Well, what we want to use it for is code that should only run when the code that we're actually testing for errors is clean. So in my case, I'm going to pull this print statement right out of here, and I'm going to drop it down into my else bucket. And the reason I want to do that is because what I'm really concerned with testing, where I think the error is really going to possibly occur, is up here in this code. It's where I'm collecting the input and I'm converting it into a float and I'm performing math functions against that code. This is the stuff that I need to check for an error. Assuming all that is clean, all that runs well, I know that my print statement can run out cleanly without any problems, and so I want that down in my else clause. That saves me some evaluation, it saves me some compile time, and again, I think it makes the code a little bit easier to read. Try except blocks can obfuscate your code a little bit, so you want to make sure that it's as easy to read as possible. Let's see it in action. Just come over here and make sure that my code is saved. Error 4.py, and I'll say again 4030, and there we go. So the code down there in the else clause executed because there was no exception raised. If I in fact had an exception raised, then we would hit that exception bucket and skip over the else clause. Now the other clause that we have inside of our try except statement is the finally clause, and similar to the else clause, it needs to be down at the bottom after all of your excepts. And the finally clause is simply code that's going to run no matter what, regardless of whether or not you hit an error inside of your try statement or not. The finally code is going to execute. It's a good place to put cleanup code. So when you start working with more advanced kind of programming, you're creating variables, you're creating objects, you want to make sure you release handles to those objects, or if you've got a file open, let's say, you want to make sure that you close your handle to that file so the operating system doesn't keep it locked. Well, down here in your finally statement is where you want to put any of that code that you might use to clean up the operations. I'll just drop a print statement down here so we can see how it executes inside of our program. Here I don't have any real cleanup to do, but I can say cleanup code goes here. Let's save that. We will run this code again, and again if I generate an error, I get my error message, and then you see my statement cleanup code goes here. But also if I generate a clean, error-free execution of this program, I get my results, and I also still have cleanup code goes here. So the finally clause is executing. That's a bucket that gets dropped into after we're done, no matter what, regardless of whether or not we had an error. And that concludes this nugget on error handling in the Python programming language. Just to recap, we talked about why we want to handle errors in the first place, why using Python's basic diagnostic output crashing down to the command line is a problem. It doesn't make a whole lot of sense for our users. They're not going to understand what went wrong necessarily, and they may lose the work that they were working on. We want to gracefully handle, gracefully degrade when an error condition crops up. And simple fact of the matter is error conditions are always going to crop up. We talked about the basic try except statement and how we can catch an error and then report back to the user that something went wrong and allow them to correct the problem. Then we took a look at accepting specific types of errors so that we could handle different types of errors that might come up inside of our code that we might expect, as well as still having a general default bucket to catch anything that we didn't expect. Lastly, we took a look at the else and finally clause so that we could run some code when our error bucket was done doing whatever it needed to do. I hope this has been informative for you. I'd like to thank you for viewing.